All right, guys, so we are going to add notes to our notebooks, and I know it doesn't seem like we have enough space on our table of contents, but we got to make space. So underneath our solving in standard form, we are going to be adding today pages 122 and 123, but I think before I write down what it is, I actually want to go do it first. So let's turn to those two pages. Oop, I'm one ahead of myself here. So here's 122, and then 123, we have it blank. So I actually need us to remember how to factor a little bit. So when we had something like x squared plus 8x plus 16, which I'm so sorry that got cut off a little bit, the way we factored it is we thought, what multiplies to 16 and adds to 8. And when something very special happened, and it happened to be the same number twice, so x plus 4 will multiply to 16 and add to 8. Excuse me. We call that a perfect square trinomial. The reason being is because I could just write this as x plus 4 squared. And anything that is squared like that is a perfect square. And it's really nice to have a perfect square like that because then I can write it out in this shorter way. And so if we think about if a number was missing, could I figure out what that number is? So what value of c, oh my goodness, c, would be factored as the following. So if I had like x squared plus 10x plus something, what would that have to be? What would that c value have to be if it factored out to x plus 5, x plus 5? So again, this is a perfect square because x plus 5 squared is a perfect square number. And hopefully we know that that c value would have to be 25. And there's kind of a couple ways we can think about it. If we know what the number is already, so like if I know it's x plus 5 squared, I can sort of just take the 5 and square it. But if I didn't know that, the other way that we can find it too is by looking at that b value, so 10, and taking half of it and then squaring it. Okay? Because if I take half of that, then I get 5. And then I square it to get the 25. So this little baby formula right here helps you to get that c value. And we need it to be a perfect square number. So that's what we're going to practice first. So if we open this side up here, to determine the value of c, that will get us a perfect square trinomial. When that c value is missing, and guys, I'm so sorry, like these got cut off. They're all x squareds in there. I don't understand how this printed so poorly, but it's so terrible. But they are all x squareds. The way we can figure it out is we just take the b number in half and then square it. So 49 on that first one. Like we take half of 14, which is 7, squared is 49. Even when it's a negative number, I'm going to take half of negative 20, which is negative 10, but when I square it, it doesn't matter. It always becomes positive, and in this case, 100. So when I take half of 12, I get 6 and square it for 36. When I take half of negative 16, I get negative 8. And square it for 16. Nope, 64. Oof. Big ol' oof. And then I forgot we were supposed to factor them as well. So if I go back and factor this now, because my mystery number is a 7, this is just going to be x plus 7 squared. Because it's a perfect square. Or this one here, because my magic missing number was a negative 10, when I factor this out, it'll be x minus 10 squared. Or this one here, because my magic number was a 6, I'd have x plus 6 squared. Or this one here, because that magic number was a negative 8, I'd have x minus 8 squared. So Thinking about two things here. We're trying to find that magic missing middle number, and then squaring it to get the C value, and factoring it to get it in factored form. Okay, so let's try a couple more. If we look at this one here, we're not even concerned with the A value too much. We're just going to take a look at B and take half. Oh my gosh, I did it in my head and then I wrote down what it was. Oops. Take half, so 4, and square it for 16. Now when I write it in factored form, that number that I just found is my magic number, and so we have x plus 4 squared when we write it in factored form, because again, like I have 2 4s for 8 and 4 squared for 16. Or this one here, if I take half the middle number, so negative 20, I already know in factored form it'll be x minus 20 squared, but I also have to find that C value. And 20 squared or negative 20 squared, doesn't matter, either way it'll be positive, is 400. Which I know it feels like that last number sort of doesn't matter either, but it does matter. All right. On to some trickier ones. Because if I take the 7, I have to take half, and it doesn't really go. So I'm going to leave it and square it, which is actually easier because then I just get to square each one. So 49 over 4 is my magic number here. And when I write it in factored form, the half is what goes inside, so x plus 7 over 2 squared. Because again, if I double that, I get 7. If I square that, I get 49 over 4. Yuck, we hate an odd number. Same thing here too. When I take negative 5 in half, I kind of can't. But if I think about factored form, I could write it right now. It's x minus 5 squared. Then I have to square it to get that magic missing C value, which when I square it, it will definitely be positive. And then 25 over 4, because we just square the top, square the bottom. And then there were more fractions. So when I take the half here, when I take and divide that by 2 again, I already have a divide bar. So I just put the other 2 down there with it. And so we get 1/4, which tells me that this is going to be x plus 1/4 squared. But I also need my C value, so I need to square it, which is 1/16, because 1 squared is 1 and 4 squared is 16. Last but not least, if I take the negative 1/3 in half, I just need to put a 2 underneath again, because I'm just dividing by 2. So I get negative 1/6. So I know in parentheses I'm going to have x minus 1/6 squared. And then I got to square it to get the magic number. And so negative 1 squared is 1, and 6 squared is 36. So 1/36. Oh my word. So the reason that we need to know all that is so that we can do this process called completing the square. So when we are completing the square, we have to follow these steps here, which again, I'm so sorry this got cut off. We got step 1, step 2, step 3, 4, and 5. Okay, so step 1, we need to isolate our A and our B from C. Okay, so for step 1, down here with my example, I need to get the x squared and x together, and I need to get that C out of there. So to get that C out of there, we're going to add 11. So we'll have x squared plus 10x equals 11. Because then, just like we were doing before, we're only looking at A and B, and we can think about what is that magic C value that completes my square. So for step 2, determine the C value that creates our perfect square trinomial and add that to both sides. So to figure out that magic C value, we have to take B in half and then square it. So B in half is 5, squared is 25. So I'm going to add 25 on this side of my equation, and whatever I do on one side, I have to do on the other. So I'm going to also add it on the other side. Now, when I add it to the left-hand side, this is now just going to be in standard form again. But over here, I can add these up for 36. Like 11 and 25 is 36. And the reason that we want to do that is because now, for step 3, on the left-hand side, I can factor my perfect square trinomial. And because it's a perfect square, it always factors the same way. In this case, we'll have x plus 5, that magic number that we found, squared equals 36. And now, something that you might be noticing, oh my gosh, you're like, and now, and more, and then, is because I only have one x, this is sort of like vertex form now. And so what we can do is just get x alone. So take the square root on both sides to get x all by itself. And so when I take that square root on both sides, the square root and square cancel each other out. We're left with just x plus 5. On this side, when I take the square root of 36, we get plus or minus 6. And then the last step, oh my gosh, I'm out of colors. Nope, I swear I have a purple somewhere. There she is. Now I can totally get x alone. So solve for x by getting x alone by subtracting 5. And so, let's color code that too. Over here, x will be alone now. And on this side, we'll have negative 5 plus 6 for 1. And negative 5 minus 6 for negative 11. And so we get our two solutions from vertex form. So you might be thinking, Missoura, why in the world did we just do all that? The process of completing the square that we were just doing, and we're going to go back and do a few more, is simply taking a quadratic in standard form, so standard form quadratic, and changing it to vertex form quadratic. And the reason that we do this is because, honestly, it's a little easier to solve in vertex form versus standard form. If you remember last week or last time we did this, solving in standard form, I had to use the quadratic formula. So like if I'm solving here, we got to use the quadratic formula, which is that crazy negative b plus or minus square root of b squared minus 4ac all over 2a. Versus if I'm in vertex form, I just have to get x alone, which is like way easier. Now there is a process that we have to go through that is kind of tricky from taking something to standard form to vertex form. So you might still want to just do the quadratic formula, but this is just another option. And there are other reasons that we maybe want to complete the square. So let's go try a few more. So solve the polynomial by completing the square, which means we're just going to take something that is in standard form, put it to vertex form, and then solve. So the first thing that we had to do was isolate our a and b, so get rid of c. So then we'll have x squared plus 8x. And I always actually like to leave a little space there because I am going to add something, equals 9. So like the key step here is to figure out what you're adding on both sides. And so to figure it out, you have to take that b number in half, so 4, and square it, so 16. So whatever number I get there is the number that I have to add on both sides of my equation. So what I have here now is x squared plus 8x plus 16. excuse me. On this side, I can actually add, so 25, and then we factor. And we don't really have to think about the x puzzle because they should all be perfect square numbers. So I just need to take the square root of the last number. So x plus 4 squared, because 4 times 4 is 16 and 4 plus 4 is 8, equals 25. Then we square root both sides to get rid of the square. So we'll have x plus 4 equals plus or minus 5. And then subtract the 4 on both sides so that we get our 2 answers. So negative 4 plus 5 will be 1, and negative 4 minus 5 will be negative 9. Let's try another. On this side, even though there's a number over here, I still have to get the x squared and x alone, so we'll subtract the 12. And so we'll have x squared minus 6x. I'm going to leave the space because I am going to add something. And then over here, I'm going to have 7 because 19 minus 12 is 7. Then to find that mystery number, we're going to take the b value in half and then square it. So we're going to add 9 on both sides. So then we'll have x squared minus 6x plus 9 equals 16. And then we got a factor. So these are the kind of 2 weird steps that people sort of forget. The take half and square it, and then the factor part. Those are the 2 big things that people forget. And so when I factor this, I need to think what multiplies to 9 and adds to negative 6, or just take the square root. So x minus 3 squared, because the square root of 9 is 3, and then the sign in the middle is minus. And then we square root both sides, because now we're going to start solving, because now it's in vertex form. And so we'll have x minus 3 equals plus or minus 4. And then we'll add the 3 over to get x totally alone. And 3 plus 4 is 7. And 3 minus 4 is negative 1 for my 2 solutions. And then I feel like we're maybe not going to do these next 2. Yep, we're not going to. The reason that we're not going to do these bottom 2 guys is because they do have an a value, and when we have an a value, it's a lot trickier, and we just don't need to worry about that yet. We'll save it for Algebra 2. Oh, those Algebra 2 teachers, they get to do so much fun stuff with you guys. All right, I know this is tricky, but try your very best, guys. You can do it.